Solving trigonometric equations is a lot like solving algebraic equations. We use algebra as a matter of fact, with the extra step of getting the final answer using our knowledge of the unit circle. So before you start these, make sure you know your unit circle really well. I'm going to start with some simple examples and then work our way up to more complicated ones. I'm going to move quickly, but remember you can always pause and go back if you need to. Okay, so here's a basic trig equation. We're going to solve 2 sine x equals 1. So let's solve for sine x by dividing both sides by 2. And from your knowledge of the unit circle, you should realize that the sine of an angle is equal to positive 1/2 in 2 places, at pi over 6 and 5 pi over 6. But that's not the only place where it's equal to positive 1/2. What about pi over 6 plus 2 pi? And what if I added another 2 pi? And I could keep adding 2 pi and I would still get an angle whose sine was positive 1/2. So to take care of all possibilities, we say that x will equal pi over 6 plus multiples of 2 pi, where n is a set of integers, and x also equals 5 pi over 6 plus multiples of 2 pi. Here's a graphical representation of that solution. You can see that it's equal to 1/2 at positive pi over 6, and then if I add 2 pi, it's equal to it again, and if I add 2 more pi, there it is again. And then it's equal to 0.5 at 5 pi over 6, plus 2 pi puts me at 17 pi over 6, and if I subtract 2 pi, I'm at negative 7 pi over 6. Okay, here we have a couple of signs, so let's get them all together, okay? So I'm going to add sine to both sides. So 2 sine x plus square root of 2 equals 0. Solving for sine x, I get 2 sine x equals negative square root of 2. So sine x is equal to the negative square root of 2 over 2. So, from our unit circle, since it's negative, it's going to be in the 3rd and 4th quadrants, and it's at 5 pi over 4 and 7 pi over 4. So our answers are x is 5 pi over 4 plus multiples of 2 pi, and 7 pi over 4 plus multiples of 2 pi. I hope you're seeing why it's important to know all your unit circle facts. We're not limited to sine when we're solving trig equations. Here's one with tangent in it. So let's solve for tangent. So 3 tangent squared x equals 1. That means that the tangent squared x equals 1/3. And tangent of x is plus or minus. Don't forget to do plus or minus when you take the square to both sides. And if I rationalize the denominator, we get plus or minus root 3 over 3. Since tangent is both positive and negative, we're going to get answers in every quadrant. Tangent of x is equal to root 3 over 3 at our pi over 6 angles. So that's the first quadrant, 5 pi over 6 in the second, 7 pi over 6 in the third, and 11 pi over 6 in the fourth. Now let's take a look at this. If I do pi over 6 plus multiples of pi, that's going to pick up the 7 pi over 6 as well. And then if I do 5 pi over 6 plus multiples of pi, that's going to pick up my 11 pi over 6. So instead of adding multiples of 2 pi, since I'm dealing with tangent, I'm just going to add multiples of pi. So x will equal pi over 6 plus multiples of pi and 5 pi over 6 plus multiples of pi. These answers give us the positive root 3 over 3's, and these answers give us the negative root 3 over 3's. Okay, here we have a mix of trig functions, cotangent and cosine. So let's get everything over on one side and see if we can factor. Do not divide by a variable expression. If you do, you're going to lose some of your answers. So you can only add or subtract, okay? Do not divide by a variable expression. So I've got cotangent x, cosine squared x, minus 2 cotangent x equals 0. And you see I can factor out a cotangent x, leaving me with cosine squared x minus 2. Okay, so let's set each factor equal to 0. So cotangent x equals 0. and cosine squared x minus 2 equals 0. Okay, cotangent is equal to 0 where cosine is equal to 0. So that's going to be at pi over 2 and 3 pi over 2. So we can cover that by just doing pi over 2 plus multiples of pi. Now over here, I've got cosine of x equals plus or minus the square root of 2. There is no solution to this one because square root of 2 is greater than 1, and remember that we can never have a value of cosine more than 1 or less than negative 1. Okay, this one looks pretty tough, but it's really not. I bet if I asked you to solve this equation, you could do it pretty quickly, couldn't you, by factoring? Well, instead of x's, we just have sine x's. So we're going to factor this like a regular quadratic. I'm going to put a 2 sine x there, and a 1 sine x in those parentheses. And I believe if we go negative 1 and plus 1, that will work. I'll get a negative 2 sine x plus a 1 sine x gives me a negative sine x in the middle, and positive 1 times negative 1 gives me negative 1 there. So that works. So let's set each factor equal to 0. And solve for sine. Okay, so sine of x equals negative 1/2. That's going to be in the third and fourth quadrants at pi over 6. That's going to be 7 pi over 6 plus multiples of 2 pi and 11 pi over 6 plus multiples of 2 pi. And sine is equal to positive 1 in exactly one place, and that's pi over 2 plus multiples of 2 pi. So all of those are answers to that quadratic. Okay, now we have stuff being squared and different functions. So what we're going to do here is make use of our Pythagorean identity, a very useful little identity, which says that sine squared of x plus cosine squared of x equals 1. I can say that the sine squared of x will be 1 minus cosine squared of x, and then take that and substitute it in for sine squared right there. So let's see what we get. 2 times 1 minus cosine squared x plus 3 cosine x minus 3 equals 0. And now everything is in terms of one trig function, which is what we like to have. So I've got 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Negative 2 cosine squared x plus 3 cosine x, and then I have a 2 minus 3 is negative 1. And let's just multiply through by negative 1. So my lead coefficient is positive, and that will factor. And I think I put a negative 1 there and a negative 1 there, and we'll get what we need. Okay, so now we set each factor equal to 0. And cosine x equals positive 1/2, and cosine x equals 1. X is equal to positive 1/2 in the first and fourth quadrants. So it's going to be pi over 3 plus multiples of 2 pi and 5 pi over 3 plus multiples of 2 pi. Cosine is equal to positive 1 at 0 plus multiples of 2 pi. And that finishes that problem. Okay, in this one I've got a mix of sine and cosine, but nothing's being squared. So guess what? We just square both sides. And it's very important that you realize you are squaring the entire side of each of the equation, okay? Not the individual terms, but the sides. So if I do FOIL on this, I'm going to get cosine squared x plus 2 cosine x plus 1 equals sine squared x. And remember that sine squared x, can't write here, can I? Sine squared x plus cosine squared x equals 1. So I can replace that sine squared with 1 minus cosine squared. Okay, so if I add cosine squared to both sides, I'm going to get 2 cosine squared x plus 2 cosine x. And then I can just subtract 1 from both sides and I get 0. So let's factor a 2 cosine x out. That leaves me with a cosine x plus 1. So 2 cosine x equals 0. That means cosine x equals 0. And cosine x equals negative 1. So cosine is equal to 0 at pi over 2 and 3 pi over 2. So I can cover all of those by just adding multiples of pi. Cosine is equal to negative 1 in one place, pi. Now, since I squared both sides, I really need to check my answers in the original problem to make sure they work. So let's go ahead and do that, okay? So let's check out pi over 2. Is the cosine of pi over 2 plus 1 equal to the sine of pi over 2? Well, that's 0 plus 1, and the sine of pi over 2 is 1, so yes, it checks. Okay, how about pi? Is the cosine of pi plus 1 equal to the sine of pi? Cosine of pi is negative 1, plus 1 is 0, and the sine of pi is 0. So they both check out, and we will use all of these answers. And here's the last example we're going to work. The difference with this problem is that I have a 3x instead of a 1x. But don't worry, it just adds one little extra step at the end. So here we go. We're going to solve for cosine of 3x by adding 1 to both sides, and then dividing by 2. For dividing by 2, so I get 1/2, don't I? There we go. So cosine is equal to positive 1/2 at pi over 3 and 5 pi over 3. So what we do is we say 3x has to equal pi over 3. 3x equals pi over 3 plus multiples of 2 pi, and 3x has to equal 5 pi over 3 plus multiples of 2 pi. And then I just divide everything by 3. So I get pi over 9 plus multiples of 2 pi over 3. And over here, I get 5 pi over 9 plus multiples of 2 pi over 3. So all that happens is you go ahead and solve for whatever's in the parentheses, and then at the very end, you divide by the coefficient of x to get your final answers.